Hello friends, myself Pratibha Raundal, Department of Chemistry of KAANMS SES College, Satana. Today I am going to discuss about the introduction about the Hammet plots. In Hammet plots, the Hammet equation in organic chemistry describes the linear free energy relationship relating the reaction rates and the equilibrium constant for many reactions involving benzoic acid derivatives with the meta and the para substituents to each other with just two parameters. The substituent constant is the first one and the second one is the reaction constant. The Hammet equation states that the relative reactivity of substituted benzene derivatives is proportional to the substituent constant sigma. For a given reaction, plot of log of k upon k0 or log of k upon k0 versus the sigma should be linear with the slope rho. Hammet equation describes the linear free energy relationship relating reaction rates and the equilibrium constant for many reactions involving benzoic acid derivatives with the meta and para substituents to each other. This equation was developed by the Louis Plack Hammet in 1937. That's why the name of the equation is Hammet equation. The basic data is that for any two reactions with two aromatic reactants only differing in the type of substituents, the change in free energy of activation is proportional to the change in Gibbs free energy. The basic equation of Hammet is the log of k upon k0, which is the equal to sigma into rho. This is the very much important equation of Hammet. Hammet equation relating the equilibrium constant K for a given equilibrium reaction with the substituent R and the reference K0 constant. When R is the hydrogen atom to the substituent constant, then sigma, which depends only on the specific substituent R, and the reaction constant rho, which depends only on the type of reaction but not on the substituent used. The relating the equilibrium constant K for given equilibrium reaction with the substituent R and the reference K0 constant when the R is the hydrogen atom to the substituent constant sigma, which depends only on the specific substituent R, and the reaction constant rho, which depends only on the type of reaction but not on the substituent that which are used in the reaction. In this equation, K0 is the reference reaction rate of the unsubstituted reactant and K that is of substituted reactant. That means you have to take here the unsubstituted reactant and the substituted reactant. When we plot the log of k upon k0 for a given equilibrium versus the log of k upon k0 for a given reaction rate with many differently substituted reactants will give the straight line. The starting point for the collection of the substituent constant is a chemical equation for which both the substituent constant and the reaction constant are the ionization of benzoic acid or benzene carboxylic acid. Having obtained the value for K0, a series of equilibrium constants are now determined based on the same process. But now, with a variation of para substituent, para hydroxybenzoic acid or para aminobenzoic acid, these values combined in the Hammet equation with K0 and remembering that rho is equal to 1 give the para substituent constant compiled in for amine, methoxy group, ethoxy group, dimethylamino group, methylfluorine, bromine, chlorine, iodine, nitro and cyano substituent. Repeating the process with the meta substituent offer the meta substituted constant. This treatment does not include the ortho substituent which would be introduced to the steric effects. Here, para hydroxybenzoic acid and para aminobenzoic acid here to the benzoic acid, here's only the difference is substituent is different, but the substituent is attached to the para position. In the first one, at the para position, hydroxy group is attached, and in the second one at the para position amino group is attached. That means only the difference is at the para position of benzoic acid the substituent is different. When the substituent is different, at that time the rate of reaction it get changed. The sigma values displayed in the table above reveal certain substituent effect with the rho is equal to 1. The group of substituent with increasing the positive values, notably cyano and nitro, causes the equilibrium constant to increase the compared to the hydrogen reference, meaning that the acidity of the carboxylic acid has been increased. This substituent stabilize the negative charge on the carboxylate oxygen atom by electron withdrawing inductive effect, that means minus I effect, and also by the negative mesomeric effect, that means minus M. The plot of Hammet equation is typically seen as being linear with either the positive or the negative slope correlating to the value of rho. However, non-linearity emerges in the Hammet plot when the substituent affect the rate of reaction or changes the rate determining step or reaction mechanism of the reaction. For the reason of former case, new sigma constant have been introduced to accommodate the deviation from the linearity otherwise seen resulting from the effect of the substituent. Sigma plus takes into the account positive charge build up occurring in the transition state of the reaction. Therefore, an electron donating group will accelerate the rate of reaction by resonance stabilization and will give the following sigma plot with the negative rho value. That means when the electron donating group is attached to the ring, at that time here the rate of reaction is accelerated. That means the rate of reaction is increases due to the resonance effect which is performed, that due to that resonance stabilization the rate of the reaction is increases, but this is possible when the electron donating group is attached because of the resonance stabilization. Thank you.